Martin's smartphone displays the diagram on the right. All right, this is the diagram. It shows how long he worked with 4 different apps in the previous week. Okay, the apps are sorted from top to bottom according to the amount of time they have been used. So this is arranged according to the amount of time he has used those apps. This week he has spent only half the amount of time using 2 of the apps and same amount of time as last week using the other 2 apps. Which of the following pictures cannot be the diagram for the current week? All right, so we want to find out which of these diagrams cannot be the diagram for the current week. All right, so let me change the color. Okay, so the key here is to note that, you know, the bars are sorted, means they're arranged from maximum to minimum, right? So this app is not necessarily this app. It can be, it may not be, depending on the time he has spent. All right, so let's check the options one at a time. Here I can see that there is 3. This is 2. So I can have this like this. So that is half. This is 2. This can be like this. So that is half. And this is the same. So this is a possible option for this week. So these 2 apps he has spent half the time. All right, so let's check this one now. Here it's 2. So I can see that this can be these 2, right? And this can be, we can extend this like here, this like so. So this is also possible for this week. In this case, I can have the first one as this one. The second one I can extend it like this. So this can be this one. And then this I can extend it another like this. And this is the same. So again, this is also possible for this week. These are the 2 apps he has spent half the time. The other 2 are the same. All right, let's check this one here. So this is 3, this is 2, this is 1. I can extend it like this here, and this is, I can extend it like this here. So this is also a possible choice for the current week. Let's take a look at this. So this is the same. These 2 are also the same. So this I can extend it like this. So here we can see that only 1 app he has spent half the time. So this cannot be a choice for this week, right? And we need to find that out. So E is the correct choice. How many positive 3-digit numbers are divisible by 13? Okay. So of course we can go all the 3-digit numbers. 3-digit numbers are from 100. So this is the smallest 3-digit number, and then all the way to 999. So these are all the 3-digit numbers. We can check each at a time, but of course that is going to take too much time. So instead what we can do is, let's divide 100 by 13, right? All right, so if we look at this division, right? So there is a number less than 100. So that is so there is a number somewhere here. So 13 times 7, right? So there is a number here that is divisible by 13, but this has to be a 2-digit number because it is less than 100. So there is another number here that is divisible. So this is 13 times 76. So there is another number here that is divisible by 13, right? And this is the largest 3-digit number because if I take the next multiple, 77th multiple, it is going to be greater than 999 from this division. How many numbers from 100 to 999? Those are the 3-digit numbers are divisible by 13. So it has to be. So there is 76, and I have to take 7 away. Take 7 away, right? So 76 minus 7, and I'm taking 7 away because these are 2-digit numbers, right? These will be 2-digit numbers, and I want only 3-digit numbers. So this is going to be 69, right? So then B is the correct choice. B is older than C and younger than L, which two can be of the same age if T is older than B. Okay, so let me write them down on the board. So B is older than C and younger than L, right? So B is older, B is greater than C, and younger, that is less than L. Now same as if Terry is older than B, right? So T is older. Older means it has to go on the right. So we can then see that L and T, so that would be, then B is the correct choice. Which of the following number is not divisible by its own digit sum? Okay, so we can check each number one at a time. 2, 0, 2, 2. The digit sum is 2 plus 0 plus 2 plus 2. So this is going to be 6. Okay. To see if a number is divisible by 6, what I can do is I can factorize 6 as 2 times 3. So for a number to be divisible by 6, it has to be divisible by 2 as well as 3, right? So for a number to be divisible by 2, the last digit has to be divisible by 2, which it is. And for a number to be divisible by 3, the sum of the digits have to be divisible by 3. And the sum of the digits we have already found out, it is 6, and it is of course divisible by 3. So this 2022 is going to be divisible by 6 or digit sum. So this cannot be the right choice. Let's check the next number, 2023. So 2023, the sum of the digits are 2 plus, I'm going to ignore 0, 2 plus 3. So 2, 2, 3. So this is going to be 7. So of course I can divide this number by 7 and check if it is divisible, but there is a quicker way. Let me show you the technique. 2, 0, 2, 3. What I do is I take out the last digit, multiply this by 2, right? So this gives me 6, and subtract whatever we get from here. So negative 6. So this is going to be 6, this is going to be 9, 196. Okay, I repeat the process. Take out the last digit, multiply by 2, I get 12, and subtract 12 from here. So this is 7. So whatever is remaining, if that is divisible by 7, then the original number is divisible by 7. So in this case it is. So 2023 cannot be the right choice. Let's take the next number, 2024. So this sum of the digits is going to be 2 plus 2 plus 4. This is going to be 8. Now for a number to be divisible by 8, the last 3, the number formed by the last 3 digits, it has to be divisible by 8. And in this case it is 8 times 3 is 24. So this is, the whole thing is going to be divisible by 8. So this cannot be the right choice. 2025. So this is going to be 2 plus 2 plus 5. So this is going to be 9, right? So again, just like 3, for a number to be divisible by 9, the sum of the digits have to be divisible by 9. And in this case it is, right? So the sum of the digits is 9, and of course it is divisible by 9. So this also cannot be the right choice. 2027. 2027, the sum of the digits are 2 plus 2 plus 7. This is going to be 11. Okay, again I can try to divide this number by 11 and see if it is divisible, but again there is a quicker trick for this. We sum of the alternate digits. So in this case 2 plus 2, that is going to be 4, and then 7 plus 0 is going to be 7. I subtract this, right? 7 minus 4 or 4 minus 7 doesn't matter. So this is going to be negative 3. If this number is 0 or divisible by 11, then the original number will be divisible by 11. In this case it is not. 3 is not divisible by 11, or right? So this 2027 is not divisible by its own digit sum, right? So then E is the correct choice. 5 to the power of 8 pencils are distributed evenly among 25 empty boxes. How many pencils are in each box? Alright, this is a simple division problem. So 5 to the power of 8 divided by 25, right? This many pencils among these many empty boxes. So it's a simple division. So I can see that 25 is a power of 5, so I can write this as 5 to the power of 8 by 5 to the power of 2, right? And so this is going to be 5 to the power of 8 minus 2. 8 minus 2. There on the top there are 8 5s, and then there are 2 5s on the bottom. So then I need to take out 2, right? So this is going to be 5 to the power of 8 minus 2 is 6, right? Now, okay, so there are some 5 powers, but I can see that all these are smaller than this, so this is not going to work, right? These are all smaller than this. So but here the base is 25. Somehow I need to convert this to a base of 25. So I can write 6 as 2 times 3. I'm factorizing 6 as 2 times 3, and then so this is same as 5 square, that is this is 25 to the power of 3, right? So this, then A is the correct choice. The product of the digits of a 10-digit number is 15. How big is the sum of the digits of this number? Okay, the product of the digits. So the product of the digits is 15. So let me try to factorize this. So this is 3 times 5. I cannot factorize it anymore. So this is the only way I can factorize 15. 3 times 5. But it is a 10-digit numbers, right? So the other digit must be ones, right? So one digit is 3, one digit is 5, and there are 8 more digits. They all must be ones, right? So then the sum is 3 plus 5 plus there are 8 ones, right? So that is 8. So this is going to be 5 plus 3 is 8 plus 8 is 16, right? Then D is the correct choice. 4 circles with radius 1 intersect each other as seen in the diagram. What is the perimeter of the gray area? All right, so we need to find the perimeter of the gray area. That means like this, right? We need to find that perimeter. So one thing to note is when 2 circles of the same radius intersect, right, the arc length is going to be the same, the intersecting arc, right? So what I mean by that, this is going to be the same as this. So instead of this, I can remove that and then have this instead. Similarly, I can remove this and have this instead. So I can remove this and have this instead. Same with this, I can remove this and then have this instead. So once we do that, as you can see, right, this is a complete circle. This is a complete circle, right? So that is the trick here, to recognize that when the 2 circles of the same radius intersect, the intersecting arc length is going to be exactly the same. So it's a full circle. The perimeter is 2 pi r, and r is 1. So then the perimeter is 2 pi, right? So then D is the correct choice. All integers from 2 to 2022 which can be written using only this is 0 and 2 are written in ascending order in a list. Which number is the middle number on that list? Okay, so let's try to come up with those numbers. So one digit, so it's the only possible choice is 2, so this means only one way, right? 2 digits, so the unit digits can be 0 or 2, but this can be only 2 because it cannot be 0. If it is 0, then it's going to be a 1-digit number, right? So this is 2 ways. Now 3 digits, so this can be again 0 or 2, this 0 or 2, this can be only 2. 2 times 1, so this is 4 ways, right? And 4 digits. Okay, so here we want to go until 2022. So again, so this can be 0 or 2. This can be 0 or 2. Here it can be only 0, right? Because I cannot have a 2 here. If I have 2 here, that is going to be bigger than this number, and we want to go until 2022, not more than that, right? Here this can also be only 2, right? Because it cannot be 0, then it's going to be less than 4 digit numbers, right? So this is 2 times 2 times 1 times 1, so this is 4 ways. So then if I arrange this in ascending order in a list, I can see that there are 3 here, there are 4 here, so then it is going to be one of these numbers, right? One of these numbers. So let's try to write down those numbers, right? So this has to be 2. The first digit has to be 2, right? The first digit has to be 2. Okay, this can be 0, 2 or 0, 2. Now there are 4 different ways, so I can start with and I want to write them in the increasing order, so I will write this as 2 0 0. Okay, 2 0 2 2 2 0 2 2 2, right? So these are the 4 different ways I can write this 3-digit number that contains only 2 or 0, right? Okay, so there are already 3 here. This is the 4. So this 3 plus 1. So these are 4. This is 4. So then it has to be the middle of this. So next is 1. This. So this has to be the middle number then. So 2 2 0. B is the correct choice. How many real solutions does this equation have? Okay, so as you can see, this is something square plus another number square. So whenever there is a square plus b square is equal to 0, whenever you see an equation like this, so a square plus b square, let's say plus c square, and if the solution we want is real, not a complex number, it's a real number, the only way this can be this equation can hold true is both a and, not or, a and b both are 0. Both a is 0 and b is 0. This is the only way we can have a square plus b square is equal to 0, because let's say a is negative, so negative square is positive. If a is or negative or positive, b square is going to be positive. So positive plus positive cannot be 0, right? So the only way a square plus b square is equal to 0 is both a has to be 0 and b has to be 0. So in this case, so it is x minus 2 square, x minus 2 square plus x plus 2 square is equal to 0. This is what is given to us. That means x minus 2 is equal to 0. So this is our a, this is our a, this is our b, right? So a square plus b square, right? And x plus 2 is equal to 0. Now what does this tell? So x is equal to 2 and x is equal to minus 2. So if we try to solve this, right, we get x is equal to 2 and x is equal to minus 2, but x cannot be both the numbers, right? So it is not possible to have a real solution for this. So a is the correct choice. Now we can check this actually. If x is equal to 2, this is going to be 0. So this is going to be 0. Then 2 plus 2 is 4. 4 square is not 0, right? Similarly, if x is minus 2, this is going to be 0, but this is minus 2 is minus 4, square of that is 16, and again which is not 0, right? So it is not possible for this equation to have a real solution. The points A, B, C, D are marked on a straight line in this order as shown in the diagram. We know that A is 12 from C and B is 18 from D. How far apart from each other are the midpoints of the line segments A, B and C, D? Okay, A is 12 from C, so AC is 12. This is given to us. And B is 18 from D, so this is 18. Okay, so let me call these segments, small a, small b, and small c. And we want to find out how far apart from each other are the midpoints of the line A, B, and C, D. So we want to find this distance. Let's say these are the midpoints. I want to find this distance, right? So it is given to me that from here, lowercase a plus b is equal to 12. That is given to us, right? So I'm calling this small a and this is small b, right? Similarly, b plus c, I'm calling this a lowercase c is this distance, plus c is equal to 18, right? Okay. So I need to find midpoint of this is a by 2 plus b plus midpoint of this is going to be c by 2. I need to find the value of this. So so somehow I want to express this so that I can use these numbers, right? So one thing I can quickly see, that is I can take the common 2's, then a plus 2b plus c, which again I want to somehow use this, right? So I can split b as b plus b. So this is a plus b plus b plus c. So 2b I am writing as b plus b, that is 2. So a plus b I know again. So I'm going to continue here. A plus b I know is 12. So a plus b I know is 12. Again b plus c I know is 18 divided by 2. So this is going to be 6 plus 9. So this is going to be 15, right? So then E is the correct choice. All right. So there is actually another way you can quickly solve this. I'm given A to C, right? A to C is given 12, and then I'm given B to D. B to D is given 18. But it doesn't tell me how far apart A is from B, right? Actually, that doesn't matter. What if I move B to A, right? If I move B to A, right? So let me just redraw this. So this is A and this is C. And I know that this is 12, right? I am trying to move B to A. So I also want B to be there, right? I'm moving B to A, right? Then from B to D is going to be, so this is going to be 18, right? So I moved B to A, right? Because seems like that should not affect our answer, right? Now then I want the midpoints of the line segments A, B and C, D. So A and B are at the same position. Let me change the color. A, B are at the same position, and then midpoint of C, D, right? So I want this distance, right? So this, as I can see, so this is 12, right? A or B to C is 12. Now how much is this distance? So this is going to be, this is 12, this is 18, so this is going to be 6, right? So this is going to be 6. This is going to be 6, and this is the midpoint. This has to be midpoints. So 6 by 2 is going to be 3, right? So this is going to be 12 plus 3 is 15. We get the same answer. 4 straight lines that intersect in one single point form 8 equal angles. 8 equal angles, okay? See the diagram, see this diagram, okay? So these are the 1, 2, 3 and 4 lines they form 8 equal angles. Let's call this angle theta. Okay. Which one of the black arc has the same length as the circumference of the little gray circle? So let me highlight the gray circle in a slightly different color so it's more visible. So instead of gray, let me make it red. So we want to find out which of these arc, A, B, C, D or E, which one of them have the same arc length as the little gray, or in this case little red, right? So always, let me change the color. So always remember the definition of theta, right? So the definition of theta is equal to L over R. So theta is the angle that is sustained by, arc length of L with radius R. So for example, so this is, if this is R, this is L, this is an arc length, right, drawn with radius R, then this is by definition. This is by definition, right? Or I can write this as, I want to check the arc length, so I can write is L is equal to R theta. Okay, so this is the equation I'm going to use. I can assume the small distance here as R. I can assume 1 or R. Actually it is not going to matter because it's going to be a multiple of that. So but just to make it general, let me assume R. Okay, so for A it's going to be L is equal to R theta. So the L is going to be, R is going to be here, the radius is going to be 1 unit, 2 units, so there is 2R times theta. So all the 8 angles are the same, so this is 1, 2 and 3 theta, right? So this is 6R theta, right? Okay, again, all that I am doing is applying this equation. L is equal to R times theta. R is the radius, and then theta is the angle, right? Then L is given by this formula. So for B, okay, this is B. B has R is equal to 1, 2, 3 again. So L is equal to 3R, 3 times R. If the one small unit is R, then this is 3 times R, and theta is 1 and 2 theta times 2 theta is equal to, again, 3 times 2 is 6 R theta. Okay, now let me check C. C is going to be this one. So it has a radius of 1, 2 and 3. So that is, again, L is equal to 3R, radius of 3R, and it has only 1 theta, right? Times theta is equal to 3R theta. Okay, let me see D now. D is going to be this one, and the radius is going to be 1, 2, 3, 4. L is equal to 4R times how many theta? You can see this is 1 theta, this is 2 theta, right? 2 theta. This is going to be 8 R theta. Okay, and then let me check E. I'm going to write E here. E is going to be, the radius is going to be 1, 2, 3, 4. Okay, L is equal to 4R times theta is going to be, this is 1, 2, 3. 12R theta, right? So, okay, and we forgot to calculate the arc length of the smaller circle. So smaller circle is going to be, so that is the smaller circle is going to be, here we have only one radius, right? That is R, right? And theta is 1, 2, 3, 4, 5, 6, 7, 8. We knew that there are 8 divisions, so that is 8 theta. So this is going to be 8 R theta, right? So that is the circumference or the arc length of the smallest circle that we have the references. So 8 R theta, so that is choice D, that is this has the same arc length as the small circle, right? So that is what we are looking for. Then D is the correct choice. A, B, C are real numbers not equal to 0. Okay, it is known that the number this and this have the same sign. Which of the following statements is definitely correct? Okay, we know that these two numbers, these are expressions, they evaluate to a number, right? So they have the same sign, right? Now, when they have the same sign, like whether positive or positive, if we multiply that, the product is going to be positive. If they have the negative, the product is still going to be positive, right? So what I will try to do is multiply them, and then I know that if I multiply these two numbers or divide, we can do either one actually. Whether we multiply or divide, the result is going to be always positive, right? So let me try to just to cancel out some numbers, I'm going to just divide it actually. So minus 2 a to the power of 4 b to the power of 3 c square divided by 3 a to the power of 3 b to the power of 5 and c to the power of negative 4. I know that this always be greater than 0 because these two expressions, they have the same sign. They are either both positive or both negative. It doesn't matter, right? They have the same sign. And when they have the same sign, if I multiply them together or divide, it doesn't matter. The product or division is always going to be positive. So this much I know. And again here, I'm dividing so that I can cancel out some, but we can also multiply. It doesn't matter. So A3, I can take out this, so only remaining is a here. So this is going to be minus 2 by 3 a, and here actually so this is going to be b square, and then if I move c to the up, this is going to be c to the power of 2 plus 4 is 6. I know that this is greater than 0. Okay. All right. Now we know that B, this is an even power. Let me change the color. So this is an even power, this is an even power, right? Any number to an even power, whether it's positive or negative, right? Any number to an even power is always positive, right? So these two numbers are always positive, right? So I can divide them. So I can take them out. 2 by 3, I also know that they are positive. So only thing that is remaining then is a and a negative sign, right? So negative a is greater than 0, right? That means a must be less than 0. A must be less than 0, so that when I take negative a, let's say negative 3, a is negative 3, then if I take negative of that, there is going to be positive 3, that is going to be greater than 0. So this is the condition that we end up with, right? So then a has to be less than 0, so this is the correct choice. We check the water meter and see that all the digits on the display are different. Okay, so all the digits are different, 9, 1, 8, 7 and 6, they are all different digits. What is the minimum amount of water that has to be used before this happens again? Okay, so one quick way is basically, we just add to this, right? Add each answer at a time, add to this and see that results in a different digit. So that is 91.876 plus 0.006. So this is 2, 7, 8, 8. So I can see that 8 and 8 are the same, right? So this cannot be the choice. That is 91.876, 0.034. So this is 0, 1, 9, 1. So 1 and 1 are again the same. So B also cannot be the choice. C is 91.876, 0.086, and I have to start checking from the smaller number, right? Because we want to use the minimum amount of water. So we need to start checking from the smallest one first and go increasing so that we can grab the smallest one. So this is 6 plus 6 is 2, 8, 6, 1, 9, 1, 9. So 9 and 9 are the same. These two digits are the same. Again, so this is not possible. Let me try this 91.876 and then 0.137. Okay, this is 3, 1, 0, 2, 9. Okay, here I can see that all the digits are the different, right? And so this is the smallest amount of water I can use. This is more than that, so this is the smallest one I can use for it to read, for all the digits to have a different number. So then D is the correct choice. All right, so actually there is another way you can think of this problem. See, we want the minimum amount of water that has to be used before this happens again, right? So what is the minimum, right? So the smallest amount it can measure is 0.001. So if you mentally start increasing by 0.001 and then see what can happen, right? So if let's say I increase 0.001, the 6 is going to be 7, right? The 7 is already there, right? So the two digits are the same, so it cannot happen, right? Even if I increase by 2, 8 is there. If I increase it by 0.003, 9 is also there, right? So we will come back to this digit later, right? So similarly, 7, if I increase by 1 or 2, those digits are already taken, right? Same with 8, if I increase it by 1, 9 is already taken, right? Then let's come to 2, let's come to 1, right? So this is the second digit. If I increase it by 1, so there is 9, 2 is no longer there. So there is going to be a 2, okay? Or let me write it here. So this has to be a 2, okay? Now if this can remain as the 9, because we want the minimum amount of water, so we don't want to increase that. Now 8, can this digit be, and we want the minimum amount of water, so I will go with 0, right? Because I want the minimum number and 0 is not taken yet, and I want the smallest digit to the left, and then 0, then 7. So here I can have 1, right? Because there is a next smaller digit. 0 is already taken, 1 is not taken yet, so I can have 1, and then I want to have 2 here, but 2 is already taken, right? So the next smallest is 3, right? So next time this meter will have all different digits. Using the smallest amount of water, the reading is going to be 92.013. There is the same result that we got here, 92.013. So if you subtract these two numbers, again you will get 0.137. So that is the correct choice. The square picture is split into 2 squares and 2 rectangles. The vertices of the shaded quadrilateral with area 3 are the midpoints of the sides of the smaller squares. What is the area of the non-shaded part of the big square? Alright, so this is a big square. This is split into 2 smaller squares and 2 rectangles. So this is the midpoint of this side. This is the midpoint of this side, right? So let me, one straightforward way is I can just assume this length to be A, and then this is also A because this is the midpoint, right? So similarly, if I assume this to be B, this is also B because this is the midpoint, then this is going to be 2A plus 2B, right? So this is 2A plus B. So if I assume this length to be A and this length to be B, then the side of the bigger square is 2 times A plus B. So let me denote A to be the area of the big square, so that is going to be square of the side. So there is 2a plus b square, right? So this is going to be 4a plus b square. Okay, now let me denote the area of the shaded part, the gray part, as g, right? So let me compute the area of that. This is a triangle, so I can I know how to compute the area of a triangle. That is half. Let me start with this part, right? Half base times height. Base and height are the same length, a, that is half a square, plus this half of base is b and height is a, so half ab, plus this one is base and height are the same, there is b and b, so half b square. So this is done, and then for this one is then base is a, height is b, so there is half ab. So this is going to be, I can just simplify it a little bit, half a square plus half ab, and half ab will become ab plus half b square. What do I want? I need the area of the non-shaded part of the big square, so area of this, right? So there is going to be a, there is the area of the whole thing, right, minus g, area of the gray part, right? So because I want the area of the non-shaded part, so this is going to be so I can simplify this 4 a square plus b square plus 2ab, right? There is a plus b square, and I can see some similarity here, so let me simplify this also. So this is 2, so this is a square plus 2ab plus b square. Okay, now, okay, so then this part, right, that is what I want. I can see that this is same as this, so this I can write, so this is basically going to be 2 times g, 2 times g, right? Okay, so a is going to be 4, a is going to be 4, a square plus b square plus 2ab, but a square plus b square plus 2ab is going to be 2g times 2g, right? So I'm just writing the bigger area in terms of the smaller area because I know the value of the smaller area, right? So 4 times this, but a square plus b square plus 2ab, that from this equation I know that this is equal to 2 times g, so 2 times g here, there was already a 4 times 2g minus this g here, g, so this is 8g minus g is 8g minus g is 7g, but g I know is 3 from here, so this is 7 times 3 is 21. Then D is the correct answer. Actually, there is another way we can quickly do this just looking at the geometry, so let me show that. Alright, so if I look very carefully at the geometry, right, can I split this like this and like this, and then also split like this? From here, what we can, so this is the midpoint, right? So this area, and this is a rectangle, so this area is going to be the same as this area. This area is going to be the same as this area because again, remember, this is the midpoint, right? So this area is same as going to be this area. Similarly, this is going to be the same. This area is going to be the same, right? Okay. So the non-gray or non-shaded part is 1, 2, 3, 4, 5, 6, 7. 7 times the gray area for this part, right? For this one, right? So similarly, this is also going to be the 7 times. If I split it like this, this is going to be the same. All these areas are going to be the same. 1 2 3 4 5 6 7, right? So basically the non-shaded part is going to be 7 times the area of the shaded part, which is 3, is 21. So without going through this lengthy calculation, if you just look at the geometry, you get the same answer, 21. What is the largest common divisor of this two numbers? Okay, so let me write down, let me try to find the factors of this, common factors, and then that will be the largest common divisor, right? So 2021 plus 2022. So I can see that, I can take 2 to the power 2021 common, 2 to the power 2021, and then this is 1 plus, so if I take 2 to the power 2021 common, this is going to be 2. So this is going to be 3. 2 plus 1 is 3 times 2 to the power 2021. Okay. Okay. And then let me try to write 3 to the power of 2021 plus 3 to the power of 2022 equal to, again I'll do the same thing, 3 to the power of 2021. I'll take that as common. So this is going to be 1 plus, there is 1 3 that is remaining here. So this is going to be 4. 3 plus 1 is 4 times 3 to the power of 2021. All right. So I want to find the largest common divisor of these two numbers, right? So there is a 4 here. So I want to try to factor out 4 from this. So this is going to be 3 times 4 times, so 2 to the power of 2021, but so this is 2 to the power of 2, so I took 2 to the power of 2 away, so this is minus 2, right? Okay. Similarly, I want to write this as 4. I want a 3 out, so then 2021 minus 1, right? So I took 1 3 out of here, so this is minus 1. Okay, now let's take a look at these two numbers, right? So this and this. So if I take a look, you can see that 3 times 4, this is a common factor, right, for both. And then 2 to the power of something and 3 to the power of something, and they are not going to be divisible by common number, because 2 to 2, 3 3 3 3, they are not going to be divisible by common number, right? So this is the only one, this is the only number that is going to be divide both the numbers. So 3 times 4 is 12, then E is the correct answer. The diagram shows a map with 16 towns that are connected via roads. The government is planning to build power plants in some towns. Each power plant can generate enough electricity for the town in which it stands, as well as for its immediate neighboring towns, that is, towns that can be reached via a direct connecting road. What is the minimum number of power plants that have to be built? Okay, so these are the towns. How many towns are there? 1 2 3 4 times 4. So 4 times 4 is equal to 16 towns. And what is we want the minimum number of power plants. So let's see what is the maximum connectivity one village can have. Let's take care of, let's see this, right? Because seems like, if we take something in the center, it will have maximum connectivity. So it can connect to this, 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 and this. So if I build it here, it can provide to 5 towns, including itself, right? 1 2 3 4 and 5. So 16 divided by 5, 3 1/5. So we know that we need more than 3. right? So we need at least four. We know that we need at least four, right? Because the maximum one power plant can provide to is five towns, and 16 by 5 is 3 and something. So we need at least four. So let me see, so this is the maximum connectivity. So let me start putting power plants at some other towns and see how many I can manage with. So if I put one here, then it can provide to this and this. Then I have to put one here because this was left out. If I provide here, I can provide to this too. I need one here because this was left out. If I put one here, then this can provide to these two villages. Now, how many power plants I have here? 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. So I'm needing 6 power plants if I try this way. But can I do less than 6? I know that I need at least 4, right? I know that, but can I make it? Can I manage it less than 6? So let me see. Let me try another configuration. So what happens is if I put somewhere in between, right? So the corners are left out. So let me try to choose something like this, right? So this can provide to this, and this. These 3 are taken care. Now, to account for this, let me put a power plant here that can take care of this, and this. Similarly, let me put another power plant here which can provide to this, and this. Okay, and then finally let me put one here which can provide to this, and this, right? So all the villages are covered. And how many power plants do I need? So this way I'm needing I have 1, 2, 3, and 4. So yes, I can manage with 4 power plants. Then B is the correct choice. In a tournament with 8 participants, the players are randomly paired up in 4 teams for the first round, and the winner of each encounter then proceeds to the second round. Okay, there are 2 games in the second round, and 2 winners then play the final. Anita and Martina are the 2 best players and will win against all others. In case they have to play against each other, Anita will win. How big is the chance that Martina will get to the final? Okay, so there are 8 participants. All right, so this is going to be the game structure. Okay, one thing to note that no matter where Anita is, she will get to the final because she is the best player. So let me try to pick a spot for her. Let's say this is A. Okay, now she is going to definitely get here because she is the best player. Now let me pick a spot for Martina. Let's say Martina is here, right? So she can make it here because she is the next best player. So here it is going to be Anita, right? Let me change the color. So this is going to be Anita, right? Because Anita is the best. Now again, Martina and Anita is going to win, right? So this place is not going to work for Martina. So this is not the right spot. Similarly, if Martina is here, right? Same story here. She can get here, but against Anita, she is not going to win, right? Same story here. If Anita and Martina play, Anita is going to win, and then she cannot get to the final, right? Martina cannot get to the final. How about here? If Martina is here, she can make it here, she can make it here because she is the next best player and Anita is not here, right? Okay, so similarly, this is a possibility. This Martina can be in any of these 4 spots and she can make it to the final because Anita is not on this side, right? as long as Anita is not on this up, Martina can always make it to the final. So out of the 7 spots that is available for Martina, 1, 2, 3, 4, 5, 6, 7. So there are total 7 spots available. Out of these 7, 4 will give her the chance to get to the final, right? And the 3 will not give her a chance to get to the final because, you know, Anita is the best player. So the chances are 4 by 7, then E is the correct choice. A cuboid with surface area X is cut up along 6 panels parallel to the sides. See this diagram. What is the total surface area of all the 27 thus created solids, right? So when I cut along 6 planes like so, there are 27 created solids, right? So 3 times 3 is 9 times 3 is 27. Okay, let me, you know, call this area A. This side is A. This is surface as B, and this surface as C. Okay, now if I make a cut like this, let me change the color. If I make a cut like this, like if I slice it like this, it is going to expose 2A. Okay, similarly, this is also going to expose 2A. Okay, now let me change the color again. Okay, if I make a cut like this, it is going to expose 2B. Similarly, this is also going to expose 2B. Okay, next, if I make this cut here, that is going to expose 2C, and similarly there is another cut here that is also going to expose 2C. So if I make this cut along 6 planes parallel to the sides, these are the areas that are going to be exposed. These are the extra areas, right? The original area is X. So let me change the color again. So the original area is X, but X is going to be equal to, there are 2 A's plus B plus C. So there are 2 of surface area A's, 2 of B, and 2 of C. So the original surface area X is going to be this. So this is the original one, and this is the amount of area that I have exposed by making the extra cuts, right? So this is then going to be, so this is, as you can see, this is going to be 4 times A plus B plus C, and this is going to be nothing but 2 times X, right? Okay, so by making these 6 cuts, right, I have exposed 2X extra area, and the original area was X. So the total after making all the 6 cuts is 2X plus X, that is going to be 3X. So C is the correct choice. The arithmetic mean of 5 numbers is 24. The mean of the 3 smallest number is 19, and that of the 3 biggest number is 28. What is the median of the 5 numbers? So let me call those numbers A, B, C, D, and E. A, B, C, D, and E. And I have arranged them in increasing order. That means A is less than B, is less than C, is less than D, is less than E. Okay. The mean of the 5 numbers is 25. So the mean is going to be A plus B plus C plus D plus E by 5, because there are 5 numbers. So this is going to be 24. Okay. The mean of the 3 smallest number is 19. So these are the 3 smallest number, A, B, and C, right? And C, D, E, these are the biggest numbers. So A plus B plus C over 3, right? Because there are 3 numbers, is 19. And then similarly C plus D plus E, C plus D plus E by 3 is going to be 28. Okay. So I need to find out the value of C. I need to find out C. Okay. So So what I can do here is, from here, a plus b plus c, this is going to be 19 times 3 is 57, and then c plus d plus c, from here, c plus d plus e is going to be 28 times 3 is going to be 84, right? I can substitute a plus b plus c here. So this is going to be 57, right? So let me write this here then. 57 plus d plus e is going to be 24 times 5, that is going to be 120, right? Now I can make use of the d plus e here, that is going to be 84 minus c. So 57 plus d plus e is going to be 84 minus c. This is going to be 120. Okay, so here I take the c to the other side. So I bring 120 to this side. So this is going to be 7 plus 4 is 11. 1, 6, 8, 141. I bring 120 to this side, minus 120. I take c to the other side. So this is going to be c is equal to 21. So that is the median, right? Then B is the correct choice. All right. A circle with midpoint at 0, 0 has a radius of 5. How many points are there on the circumference where both coordinates are integers? Okay. So let me call a point on the circumference as x comma y, right? So for a circle, then x square plus y square is going to be r square, where r is the radius, and in this case radius is 5, so 5 square is 25. So essentially I have to find pairs of x and y such that when I square them up and add them, it is going to be 25, and x and y both have to be integers, right? So let me write down the different possible options. One is, we already know, it is shown here, that is x is going to be 5, y is going to be 0, right? X is going to be 5, y is going to be 0, that is one possibility. The other one is, I can split up 25 as 16 plus 9. So this is going to be 4 square, and this is going to be 3 square. You can also try other combinations, right, to get to 25, but you will see that these are the only two integers, that when you square them up and add them up, you get 25. So it can be 4, 3, or it can be x can be 3, y can be 4. It does. So these are two different points, right? 4, 3, and 3, 4. So let me draw these points here. So one is going to be 5, 0. So 5, 0 is already here. 4, 3, 1, 2, 3, 4, and then so this is going to be another point. 3, 4, 1, 2, 3. So these are the 3 points on the first quarter whose coordinates are going to be integers, and these are the coordinates. Similarly, as you can imagine, there are going to be 3 points on this quarter. Let me draw those. One is, we can already see one here. The other one is 1 to here. The other one is going to be 4, 3, right? So 3 here, 3 here. Similarly, there are going to be 3 here and 3 here, right? So there is 3 times, there are 4 quadrants. So there are going to be 12 points whose coordinates are going to be the integer, right? So then C is the correct choice. The vertices of a pentagon are level using the numbers 1 to 20, so that adjacent vertices always differ by 1 or 2. The sides of the pentagon whose vertices are level with numbers that only differ by 1 are drawn in red. How many red sides does the pentagon have? So pentagon basically is a 20-sided polygon, right? So let me start numbering it. We call it 1, and then 2. Now if I continue numbering like this 3, 4, 5, 6, then I will end up with 20 here, and the difference is going to be more than 2, right? So, but we want to number such that the difference is going to be always 1 or 2. Then what I can do is 1, 2, then I can have 3 this way. So the difference is 2 here, the difference is 1 here. Now if I have 4 in this case, 5 will go here, but then the difference is going to be 3, so I cannot have 5 here. So let me put the 5 here, then 4 here, and then 5 here. Then the difference is going to be, you know, 2 here, 2 here, and I can continue like that, 5, 6, 7, like this, and then I will get to 18, and here is going to be 19, and there is going to be 20, right? Here, as you can check, two adjacent vertices, they always differ by only 1 or 2, right? So let me mark in red, those differ by 1, okay? So this one differs by 1, and everywhere else this is difference of 2, 2, 2, but this is going to differ by 1. Everywhere else the difference is going to be 2, right? So all these will differ by 2, right? So there are only 2 sides, they will be marked in red, so then B is the correct choice. Which of the 2 building blocks can be joined together so that the object shown is created? Okay, so which of these pairs I can join together to recreate this object? So this is a 3D problems and requires some imagination. To make it easier, let me number these blocks. Let me number it 1, 2, 3 is behind this, that is hidden, and then this is 4, 5, 6, 7, and 8. So this is a 4. Okay. Now, if you think about it, let me consider this block here, right? Now, how can I get that? I can take 3 that is hidden behind, so this can be 3. This can be, the top one can be 4, this can be 5, and this can be 7, right? 3, 4, 5, and 7. If I take 3, 4, 3, 3 is hidden, 4, 5, and 7, I'm left with 1, 2, 8, and 6. So as I can see, 8 and 6, they don't even connect on a face, right? They just touch on the edge, so I cannot get this structure, right? So that is not a possible choice. Now, so this is the same structure here. So if I take this out, there is no way I can get this structure. Again, if I take this, there is no way I can get this structure. So we can eliminate these 3 because, you know, as you can see from here, if I take 3, 4, 5, and 7, 2 of the blocks, they don't even connect on a face, right? They just touch on the edge. Okay, so I'm left with these 2 choices, A or B. So A can be, this can be 1, 2, right? And then this can be 3, that is below 4, and then this can be 7. So 1, 2, 1, 2, and then 3 and 7 are like this. Okay, now can I get this structure? Okay, if 1, 2, 3, and 7 are taken, what I can do is this can be my 5, this can be 6. If I tilt it like this, right, 5 and 6, so 6 is touching with 4, so this is 4, this can be 4, and this can be 8, right? So seems like this is a possible choice. 5, 6, if I tilt it like this, 4 and 8 are going to be like this. Okay, now this is the same, as you can see. So this is 1, 2, 3, and 7. Now if I do this, can I get back this structure? Okay, if I call this 8 and this is 4, right? 8 and 4, the 6 is touching 4, so this can be 6. And then as you can see, this is pointing to the top, not to the bottom. I needed something on the bottom, right? This is 4 and 8, 4 and 8, 6 is touching 4, and then 8, sorry, the 5 should be here, 5 should have been here, right? 5 should have been here. This should have been 5, not this, right? So this is also not going to work. Then A is the correct choice. A rectangle is split into 11 smaller rectangles as shown. All 11 rectangles are similar to the initial rectangle. The smallest rectangles are aligned like the original rectangle. The lower side of the smallest rectangle has length 1. Okay, so this is 1. How big is the perimeter of the big rectangle? Okay, so what does it mean by two rectangles are similar? Let me draw the two rectangles. This is 1. So let me call this side A, this is B, this is C, this is D. So a rectangle typically has a longer side and a shorter side. So the ratio A over B is C over D. When we say that two rectangles are similar, basically this is what we mean. The ratio of their sides are the same, right? So basically they have the same aspect ratio. Okay, so let me call this length as X and this as Y. Okay, now let me call this smaller height as H, right? This is as H. Okay, it says that the smallest rectangle, that is this, is aligned like the original rectangle. So they are aligned the same way, the small and the smallest and the biggest. So that means 1 over H is going to be, the side corresponding to 1 is X, right? X over Y. But what is Y? Y is going to be, in terms of H, there are 9 of the smallest rectangles, so that is 9H, right? Okay, so here I can cancel out H. So this tells me X is equal to 9. Okay. Okay, so I found X. Now what about Y? If we look at this, the medium rectangle, that is this and this, these two rectangles, the Y is the same, right? So this base has to be the same. So this has to be the same as this, right? But the whole thing is 9, we just found out, and 1 is already taken here, so this must be 4, this must be 4. Okay, so finally I want to write down this similarity condition, let's say for the big triangle and this medium triangle. So X over Y. Okay, so this is going to be the length for this, this is going to be the width, right? So length, this is length is Y and width is going to be 4, right? So length over width for the biggest rectangle, length over width. For the medium rectangle, the length is going to be this and width is going to be this, 4. So from here I can see that X I have already found to be 9, right? So Y times Y is Y square, Y and Y square, and X is 9, so 4 times 9, right? So then Y is going to be simply square root of this is 2, square root of this is 3, so this is going to be 6. So then X is equal to 9 and Y is equal to 6, right? So the perimeter is then going to be 2X plus 2Y, right? So that is going to be the perimeter, this plus this and this plus this, and X I already have 9, so that is 18 plus 12, right? Y is 6, 2 times 6 is 12, so this is going to be 30, right? So the perimeter is going to be 30. Then D is the correct choice. Two rectangles are inscribed into a triangle as shown in the diagram. The dimensions of the rectangle are 1 by 5 and 2 and 3. How big is the height of the triangle in A? So we need to find out what is this height. Okay, this should ring a bell. We need to make use of the properties of similar triangle. Okay, then let me name the nodes A, B, C, D, E, F, G, H, I. Okay, and I know that this is 1, so this height is going to be 1, right? This is a rectangle. If this whole thing is 2, 2 minus 1 is 1, so this is going to be 1, 2. All right. Okay, let me call this side, right? This side edge H. Okay. Now I want to write down the ratios. A E over DF, this must be equal to AH over GI. Okay, so this is what I'm doing. AE over DF, right? That must be equal to AH times GI, right? So this is from the properties of similar triangles. And this is a similar triangle because this is the same angle and these two lines are parallel. Okay. Okay, so let me write down those values. AE is going, I have assumed that to be H over DF. DF is going to be 3. AH is going to be H plus 1. GI is going to be, this is 1 over 5, so this is 5, right? So this tells me that 5H is equal to 3H plus 3, right? So this tells me 2H is equal to 3. This tells me H is equal to 3 by 2. Okay, I want to find the total height, right? So the total height is H plus 2, right? So this is H, you just found out 3 by 2 plus 2. So this is going to be 2 and 3 plus 4. So this is 7 over 2, right? Then B is the correct choice. How many 3-digit numbers are there that are equal to 5 times the product of their digits? Okay, so let's take a 3-digit number A, B, C. This number is 5 times the product of their digits, that is A, B, C. Okay, so this is the hundreds place, this is tens place, this is ones place. Okay, of course we can try out all the 3-digit numbers from 100 to 999, but there are too many numbers to try, right? So let's see, given this requirement, if you can deduce some conditions so that we can narrow down the choices. Okay, first I can see that since it is the product, none of A, B or C can be 0, because if let's say one of the digit is 0, then this whole product is going to be 0 and this 3-digit number cannot be 0, right? So none of A, B or C can be 0, right? Okay, so there is the first condition. The second, okay, now 5 times something, right? So 5 times an even number always ends with a 0, right? 5 times 4, 5 times any even number ends with a 0. Therefore, if any of A, B or C are even, then the whole product ABC will be even. If one of A, B or C is even, then the whole product is going to be even, and then multiplied by 5 will end up with a 0 at the unit place, right? That means if any of A, B or C is even, then C must be 0, but C cannot be 0. We already figured that out. So none of A, B, C can be even. Therefore A, B, C all must be odd numbers, odd digits, right? So A, B, C all must be odd digits. Okay, all right, so number 3. Now if they are all odd, 5 times a odd digit, right, always ends with 5 at the unit place. Like 5 times 3 is 15, there is a 5 at the end. So 5 times A, B, C, if A, B, C are all odd, then the whole product is going to be odd. 5 times the odd number is going to end with 5 at the unit place, right? So then C must be 5. So C must be 5, right? Okay, C is equal to 5. Okay, all right. Now, if C is 5, 5 times ABC, 5 times A, B, C, and C is 5. So 5 times 5 is 25 AB. Okay, so if C is 5, 5 times 5 is 25. That means the 3-digit number must be divisible by 25. So it is of course divisible by 5, but it has to be divisible by 25 from here, right? Okay, so and then divisible by 25. Okay, so these are the 4 conditions we can deduce from the requirement that is given to us. Once we have that, we can narrow down the 3-digit numbers and see which one works. So for example, let's write down all the 3-digit numbers that satisfy these 4 conditions, right? We can start from 100. So 100 is not going to work because it has zeros. Similarly, 125 is not going to work because 2 is a even number. 150 is not going to work because 0 is not allowed. Then 175, right? And then 200 is not going to work, it has a 0. And then similarly, we will see that 375 is the next one that is going to work. 575, 775, and then 975. Okay, so we narrowed down the 3-digit numbers to these few numbers, right? And we can now check one at a time. So 7 times 5 is 35. So 35 times 5, so 175. So 7 times 5 is 35, times 1 is still 35. Then if you multiply that by 5, so 175, right? So 175 is a 3-digit number, and that satisfies this condition, right? It's 5 times the product of the digits. So 175 is 1, so this works. We can check 375. So 7 times 5 is 35, times 3 is 105, times this 5. So this is going to be 525. So okay, so we started with 375. If you multiply the digits, right, we end up with 105, and multiply that by 5, we end up with 525. 525 and 375 are not the same, right? So 375 is not going to work. Similarly, we can check the other numbers and verify that these are not going to work. So there is only one number that satisfies this condition, right? Then A is the correct choice. The numbers 1 to 10 were written into the 10 circles in the pattern shown in the picture. So this is the picture. The sum of the 4 numbers in the left and the right column is 24. Okay, the sum of these 4 is 24. This sum is 24. And the sum of the 3 numbers in the bottom is 25. So this is 25. Which number is in the circle with the question mark? Okay, so which number is here? Okay, so we are dealing with the sum of numbers, and we have the numbers from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, if I add all the numbers, I will get, remember the formula for adding consecutive numbers. So 10 times the next number 11 divided by 2. So this is 5. So I get 55. All right. So I get 55 if I add all the numbers. So if I add all the numbers, I get 55, right? Okay, so let me, this, if I add these numbers 24, if I add these numbers 24, and if I add these numbers 25. Now, if you see here, right, I am not counting one number. Out of these 10 digits, one is not accounted in this sum. 24, 25, and 24. In this, one digit not accounted, and these two digits are, or these two numbers are double counted. Okay. So, okay, first let me find out. So 24 plus 24 is 48. 48 plus 25 73. Okay, so 73. Now let me subtract 73 minus 55. So this is going to be 18. Okay, so let's think about it for a moment, right? I'm not counting one of the numbers, so I have removed one of the number, and two other numbers are double counted. Then I get the total sum is 73, which is 18 more than if I added all the digits, right? So in these numbers from 1 to 10, I have to discard one number, and two numbers I have to double count to get this sum, right? So this is 18. Now if you can see, right, if I, which two numbers I can add up to 18? 10 and 8 and 10 add up to 18, right? But I have also to discard one number, right? If I discard 1, right, if I discard 1, so I'm losing 1 there, so then I have to add one more here. So then I have to add 10 and 9. So if I add, double count 10 and 9 and then discard 1, then I get, then that I get 73, right? Because so 10 plus 9 is 19 more, but I'm removing 1, then I get 18. Can I discard any other number? Let's say if I discard 2. If I discard 2, there is no way I can get a sum of 18, because it has to be 10 plus 10, and I cannot double count the same digit, right? So as you can see, these 10 places must be occupied by these numbers, right? Then and only then, and 9 and 10 must be here. 9 and 10 must be here, these two, right? Then and only then I satisfy all the conditions. So this number must be 1. So this number must be 1, right? Okay, so then it's not going to be 2, 4, 5, or 6. It is going to be another number, because it has to be 1, right? So one way you can see this working is, right, so let me have 9 and 10. So we can have, let me erase this here. This can be, say, 9. This is 10. And I know that this is going to be 1. And I want to add this to 24, and I need to add 4 numbers, 24. 4 numbers to get 24, right? So average is going to be 6. So it is going to be about 6, right? Okay, so so I can have 10, 2, and 9. I need it in other column. So let me triangle it. 9 can go with 3, 4, and 8, 5. Okay, so if I do it like this, 2, 4, 8, 10. So 2, 4, 8, 10. They add up to 4 plus 2 is 6, plus 8 is 14, plus 10 is 24, and then 3, 5, 7, 9. 3, 5, 7, and 9. So they add up to 8, 15, 9, 24. Okay, and then I have 6 here. 6 here, and This is 10 plus 6 is 16 plus 9 is 25, and then 1 goes here, right? So this is one of the configuration. Of course, I can move these numbers around. 2, 4, 8 can switch places, it doesn't matter, but we need a 9 and 10 at the bottom, right, from this condition. A square is placed in a coordinate system x zone. Each point xy of the square is deleted and replaced by the point 1 over x, 1 over y. Which diagram shows the resulting shape? Okay, so x transforms to 1 over x and y transforms to 1 over y. Okay, so if I look at this shape, so this coordinate is 2, 2, and this is 1, 1. So let's try to see where these 2 points go, right? So 2, 2 will transform to, this is 1 over x, so 1 over 2. So this is going to be half over half. So this is 0.5 and 0.5. So this point is going to go to 0.5, okay? And this point is going to 1, 1, 1, 1, 1 is going to go to 1 over 1 is just 1, 1. So this point is going to remain the same. So we need a point at 1, 1 at 0.5, 0.5. So this has that, okay? 1, 1, 0.5. So this is not going to work. 1, okay? So this is not going to work. 1, 1 point. So this is not going to work, okay? Now, if you look at this line here, x coordinate is the same for all the points on this. X coordinate is the same. So the only difference between these two are, here I have x coordinate the same, here it is slightly curved. So definitely this is not going to work. Then C is the correct choice. Let n be a positive integer. How many integers are between this and this? Okay, so if I can find a bound for this number, integer bounds, and find the integer bounds for this, right, it will be easier for me to get the count the number of integers. So let me write down. So n square plus n plus 1 and square root of that. So I know that n plus 1 square is going to be n square plus 2n plus 1, right? Here there is a 2 here there is only 1n, right? So this has to be less than n plus 1, right? Because n plus 1 has 2n and n is a positive integer, and this is clearly greater than n, right? Because it is n square, I'm adding this extra thing, so this is going to be greater than n. Similarly, 9n square plus n plus 1 square root of that. So 9n square, so this is 3n square, right? So 3n plus 1 square is going to be 9n square plus 6n plus 1, right? So this number is then going to be greater than 3n, because 3n is square of 3n is 9n square, and there are extra things, so it is going to be greater than 3n, and it has to be less than 3n plus 1, right? Because 3n plus 1 has this 6 in here, and there is only 1n here, so this has to be less than 3n plus 1, okay? Then how many integers are between these two numbers? So if I take a number line here, this is n plus 1, and then here is 3n, and here is 3n plus 1. Now this number is less than 3n plus 1, so this number is somewhere here, right? This number is somewhere here, less than 3n plus 1, but it is greater than 3n. Now this number is greater than n but less than n plus 1, so that number is somewhere here, right? So how many integers are here? So that is simply 3n minus, I subtract n of those integers, minus n is equal to 2n, right? So then C is the correct choice. A sequence AN has A1 between 0 and 1. Okay, for all n greater than or equal to 1, we know that this and this. We know that A7 is equal to 2. What is the value of A2? A7 is given. We need to know A2, and there are some equations given, so we need to somehow connect back A7 to the lower ANs. So let me write down the sequence as A1, A2, A3, A4, A5, A6, A7. A7 is 2, that is given to us. Okay, so let me write down these relations. A2n is equal to A2 dot AN plus 1. A2n plus 1 is equal to A2 dot AN minus 2. Okay, let me call this equation 1, equation 2. All right, from here I can see that A2an, A2an are the same, so I can subtract this from here. So this will be A2n minus A2n plus 1 is equal to, this term will cancel out. So this is going to be 1 minus of minus 2, that is 3. So this is equation 3. So from using this, given A7, I can find A6. So let me write down, if n is 3, this is going to be A6 minus A7 is equal to 3. Again, n is 3, so 3 times 2 is 6. 3 times 2 is 6 plus 1 is 7. So A6 minus A7 is equal to 3. But A7 is 2. A7 is 2. So this tells me A6 is going to be 3 plus 2 is 5. Okay. So A6 is 5. I can write that down here. All right. So one thing to note here. So let's kind of map the ANs, the way they are related here. Let me use a different color. Okay. I see that, you know, a even AN is connected with A2 AN. For example, A6 is connected with A2 and A3. So when n is equal to 3, 3 times 2 is 6. So A6 is connected with A2 and A3. Okay, let me add another color. And the odd an plus 1, again if n is equal to 3, then is 7. A7 is connected with A2 and A3. A7 is connected with A2 and A3. Okay, so this kind of depicts these two equations, the way they are related. And let's see this one, A2n and A2n plus 1. Let me add another color yet. Okay, so if n is equal to 3, then this relates 6 and 7. So A6 and A7 are related. And similarly, if n is equal to 1, then A2 and A3 would be related. Okay. Okay, so these are the relations we have. And I need to find what is A2. So I can again use this relation, right? This equation for A2 and A3. So let me do that. So if n is equal to 1, this is going to be A2 minus A3. N is equal to 1, so 2 times 1 is 1 plus 1 is 3. This equal to 3. Okay, so let me call this equation 5. All right, so I found a relation between A2 and A3. Okay, to find A2, I need another equations relating A2 and A3. So if you want A2 and A3, n is going to be 3, so this is going to be A6, and A6 I already know. So let me write down this equation. So this is going to be A6 equal to A2 times A3 plus 1. But A6 I know is 5. We have already found that out. Okay. So this tells me A2 times A3. This is going to be 5 minus 1 is equal to 4. Okay. So this is equation 6. Okay. All right. So I have two equations and two unknowns, a2, a3, a2, a3, and I can solve it. So let me write down this equation. I need a2, so let me replace a3. So a2 minus a3. a3 I'm going to see it from here. a3 is going to be 4 by a2. 4 by a2. That is equal to 3. Again, I'm using the equation 5. a2 minus a3, and I'm substituting a3 from here. a3 is equal to 4 by a2 is equal to 3. All right. So this tells me a2 square minus 4 is going to be 3a2, right? So this is a quadratic equation. So this is a quadratic equation. Let me call it equation 7, right? And I can easily solve for a2. I'll spare you the details. So the solution of this is going to be a2 is equal to either 4 or -1, and we can check it. If it is 4, then 16 minus 4 is 12, and 4 times 3 is 12, so 4 is a solution. -1 square is 1, minus 4 is -3, so 3 times -1 is -3. So these are the two solutions. These are the two possible choices, 4 and -1, and I can see that 4 is one of the possible answer here. So looks like that is the correct choice. However, we have another condition here, that this one, a1 has to be between 0 and 1. So let's see how, if we can satisfy that. All right, so if I look at this equation, equation number 1, if I use n is equal to 1, that is going to relate me to a2 and a1, right? And I already know a2, so I can see the limit for a1. Okay, so let me write down equation 1 for n is equal to 1. So this is going to be a2 is equal to a2 times a1. Again, n is equal to 1, so it is a2 is equal to a2 times a1 plus 1. Okay, so this tells me a1 is equal to, I'll bring 1 to this side, a2 minus 1, a2 minus 1, and then I divide by a2. Okay, so this given a2, this is my a1. Okay, so let's see, if a2 is 4, 4 minus 1 is 3 by 4, and that is between 0 and 1. Okay, so for 4, if these are the values of a2, 4 or -1. So if a2 is 4, and then 4 minus 1 is 3 by 4, so then a1 is going to be between 0 less than a1 less than 1, right? However, if it is a2 is minus 1, so this is going to be minus 2 by minus 1, so this is going to be minus 1 by minus 1, so this is going to be -2, so this is going to be 2, so this is going to go beyond, so a1 is not going to be less than 1, it's a1 is actually greater than 1, so then -1 is not going to work. 4 is the correct choice, then D is the correct choice. Two circles intersect a rectangle AFMG as shown in the diagram. So this is the diagram. The line segments along the long side of the rectangles that are outside the circles have length. Okay, these are the lengths also shown here. How long is the length x? How long is x of the line segment LM? So we need to find out this x. Okay. Notice that we are not given the radius of the circles, right? So probably we don't need it. Okay. Another thing is, for a rectangle, these two sides are parallel, right? So this is a chord, BC is a chord, HJ is a chord. So somehow I need to make use of these lengths, right? And find out what is x. So one thing that I can do, if I draw a bisector of this chord, BC, this is a chord, right? And then if I draw a bisector, it goes through the center, and then it is also going to bisect the chord HJ, right? So if I call this A, this will also be A. If I call this B, this will also be B, right? So this is same as this, it's a bisector. This will also bisect, so B is same as B. Similarly, if I draw a bisector of one chord, perpendicular bisector, right? It's going to go through the center, and this is going to be, let me call this C, this will be C, and this will be D and D, right? Okay, I don't know the value of D, but what I know is if this is D, this is also going to be D, right? It's going to bisect. Okay, now so somehow I will try to add the lengths now and see if I can figure out X. Okay, so let me use a different color. So the first path that I'm going to travel is if I go like this, here, come back and go all the way. Okay, so this is one path that I'm going to travel. Okay, now the length of that path is going to be 8 plus A, and then I'm only going to calculate the horizontal length, right? Because I'm only given the horizontal length, so I'm not going to include the vertical length. So B, this is B, and then this is 24, and then this is D plus C, this is C, and then plus 22. Okay, now let me use a different color. I will construct another path that I will travel like this. Here, go up. Okay, again here, this is a red line. Okay, now what is the length of that line? So it's going to be 12 plus B plus, I go here, A plus 26, and then C, and then come down and I have D, and then I have X plus X. Okay, okay, now what is the relationship between this length and this length, right? As you can see, they are going to be the same, right? They are going to be the same. Why? Because the horizontal length of the green line, that is the length of the side of this triangle, right? Similarly, if I just take the red line, only the horizontal line, this also is length of the rectangle, right? So the horizontal portion of the green line and the horizontal portion of the red line, they have to be the same, right? Okay, now from here, as you can see, I can cancel out A, cancel out B, C, D, right? So all I'm left with is X as the variable, everything else is known. What I can do is I can also probably take out this 12, so only remaining is 12 here. Okay, so let me write this down. 8 plus 12 is 20 plus 22 is 42, equal to, this is 26 plus X, right? Okay, then X is going to be basically 16, right? So X is going to be 16. Then C is the correct choice. Here basically the trick is to recognize that, you know, somehow we want to make use of the chord length and the fact that if we bisect the chord, it is going to also bisect the other chord that is parallel to it, and figure it out.